Hi everyone. Today we will continue our lesson on the life cycle of a star. Yesterday we did low mass stars. Today we will do high mass stars. So what is the difference between a low mass star and a high mass star? So a low mass star is smaller. That is the biggest difference. That is smaller. A high mass star is much more massive. Because it is so much bigger, its life is very short. Okay, so this is kind of a representation of how short its life is compared to a low mass star. Okay, once again, so how long do they live? A high mass star can live up to tens of millions of years, whereas a low mass star can live up to billions or trillions of years. So our high mass star has a much shorter life than low mass stars. Now that we have an idea of what is a low mass star, what is a high mass star, we can move on to the actual life cycle of a high mass star. And so our life cycle starts here with our main sequence star, just like the low mass star. Okay, hydrogen is being fused into helium. And just like the low mass star, it has the same forces. The gravity is pulling inward and the pressure is pushing outward. So actually at this point, I'm going to copy and paste this exactly into my high mass star because it's the same thing that's going on. This star is just bigger. Okay. And so the number of years, because the star is bigger, it is not a main sequence as long. Okay, so which one has a longer main sequence? The high mass or the low mass? The low mass has a longer main sequence. Okay, low mass, longer. Okay, high mass, short life. Okay, so after it uses up all its hydrogen, just like the low mass, it becomes a giant. Because this was already giant, now we're going to call it a supergiant. The low mass, we called it a red giant. For the main sequence, we're going to call it a supergiant because it is just so big. Okay, so our supergiant at this stage, we are going to convert the helium and we are going to make elements all the way up to iron. So nuclear fusion is making elements all the way up to iron. Okay, if I were to pull up a periodic table, let's just look at one quickly. So the low mass star, it was making carbon and oxygen. Okay, with my high mass star, we're going to make all of these elements, all of these elements, all of these elements up to iron. Okay, where's my tab? Okay, so nuclear fusion is making elements all the way up to iron. When it starts making iron, nuclear fusion stops. It stops completely. Okay, iron starts to form. Nuclear fusion stops completely. Why does it stop completely? Well, technically because in the elements smaller than iron, nuclear fusion releases energy, and we get energy from it. But bigger than iron, it actually takes energy, and so it would just be taking energy from the star, which would just kill it. Okay, so nuclear fusion stops completely at iron. But oh no,